Am I audible? Hello. Yes, anyone?
Yes, sir.
Okay, thank you. Yeah. So we'll wait for a couple of minutes, then we'll start. Okay. Let others can also join. Okay, so yeah. Good morning once again. Yeah. So how was the quiz paper? Yes, anyone? Any comment on that? Hello.
Hello, good morning, sir.
Good morning. Yeah.
Sir, it was like more theoretical as compared to earlier.
More theoretical.
Yes, sir, that's what I observed.
Uh,
Earlier, the questions were most active, practical based, but it was like some more questions were theoretical based this time.
okay. Theoretical.
And it was easy, so
Okay. Then quiz one, right? Easier than quiz one.
yes, sir.
Okay. Yes, any other student? Anyone? Abhishek is there? Hello, yes, anyone? How was your quiz paper?
Question was easy, sir.
Yeah, question paper was easy, right? Okay. Like most of the concept was covered in the mock test only.
Yes, sir. Yes, sir.
Yes, sir. The paper was very balanced.
Mhm. Okay. Okay, thank you. Yeah. So today at first we are going to take grade part. So that is from week 11, and after that we can discuss week 12 content. Okay. So okay. So how many of you have watched the week 12 lecture? First two lecture at least. Okay, only one student. Okay, fine. Yeah. So first we'll start with the week 11 grade part. Then we'll move on to week 12 content. Okay. So yes, yeah. Pradeep, yeah, you can continue.
Yeah, thank you, Piyush, sir. Good morning, all of you. So today we'll first discuss about the red part. So let me share my screen. Uh, Hello, is it visible to everyone, right?
Yes, sir.
Yes, sir.
Yeah, thank you. So, uh, have you, how many of you watched the 11.5? Hello, only Vriash. So, can you tell why we use the red? Anyone? Just so why is it is required to us? So suppose you have a single disk, right? So if by any system failure your disk got corrupted, right? So that time your every data will get lost. Means you lose your information, all the information. So for that we use the several disk at a time. So we create a array of disk and right means collection of disk, right? Okay, and it is a behave like only a single disk, right? So it seems like only one disk, right? But in the backend it is several disks work on that. So first let me tell. So this is the RAID is this, the full form of RAID is a redundant array of independent disks, correct? So first we can see the it is the disk organization technique and that manages the large number of disks and provide a view of the single disk, right? So by we can gains the high capacity because and also gets the high speed, and we after see the when we see the RAID level how we obtains the high speed, then we can see and how this disks are used for the in we can use in the parallel, and the one of the high reliability. High reliability means if one disk got corrupted or got failures, then also we can get our information by mirroring technique, or some there is the one RAID level is there when we can recover our information, lost information, right? And yesterday's the previous session we have discussed about the MTTF, that is the mean time to failure, and that is the a disk is run that is the average time for that disk run without any failure, right? So for example, suppose there are the 100 disks and the MTTF of the one disk is the 1 lakh hour, right? So what is the MTTF of that system? So anyone can tell how to find that? Hello?
Sir, MTTF is equal to number of hours disk is used divided by total number of disk which got failures.
Yeah,
Failed.
yeah. That is the suppose. I did not like this, right? These are the disks, and this system contain have 100 disks, right? And the one disk MTTF is that is given 1 lakh, right? So that is the one. What will be the uh, MTTF of that system? So that means what the minimum uh, without how the system is continuously run without any failures, and that is the average of that. So that is right, and that is 1000 hour. I hope MTTF is clear to everyone. Hello, am I audible, right?
Yes, sir, you are audible.
Yeah. And so this is another alternative of that. So the I is to stand for the inexpensive, right? So we know that's the most costly is the register, after that the cache, and after that that RAM, and uh, secondary memory after, and the after comes the magnetic disk, right? So now we see the what redundancy. So redundancy means we know some extra information, or the we also read in the normalizations the same copy of the data we kept in the database system, that is known as the redundant, right? So keeping the redundant information, we can achieve some of our motive. That's the if one disk got failures, then we can extract some information, or read the information for the another disk, right? And after that we comes to the means mirroring means same the copy of that same data, right? Suppose
Sir, I
this
have
is
a query.
yeah.
Sir, in MTTF, there was a question in previous quiz,
Yeah.
in last term quiz, which I solution, which is the solution of which I saw in portal, but
Yeah.
I was not able to understand the solution given by Subhendu sir.
uh, what was the question?
Sir, there was question. Let me.
It is in the last term, right?
Yes, sir, it was in the last term, and the question was about that 15. We need to find the probability that 15 discs are selected. Then what
Okay.
will be the
Yeah. So
30 discs for work for 24 hours maintenance, and 15 discs failed after 18 hours, 8 failed after 22 hours, and 7 never failed. What MTTF for 15 discs randomly selected?
okay, let me check that question. Pradeep, can you complete this after that? We can take that. Right?
Okay.
Yeah. Is that okay, right?
Yes, sir.
Yeah. So Just okay. So we discuss about the mirroring, right? So mirroring means we makes the duplicate of that disk. Suppose this is the disk one, and it store the block, right? A1, A2, A3. We make the same copy of the another disk and contains the same information, right? That is known as the mirror, right? So whenever we want to write anything, means we want to write the information, suppose B1. So at that time we have to write on the both the disk, right? So but in case of the read operation, we can write it from the either disk. Means you can write from this disk also and this disk also, any one. So this is the one advantage of that. If one disk pair in a pair, one disk is fail, still the data is available to you, right? So after we see the striping part, the striping in the bit level striping, right? So can anyone tell in the 1 byte how many bits are there? In 1 byte,
8 bits, sir.
8 bit, right? So for that, assume that there is the 8 disk is there. So think 1 bit. So suppose there is the 8 disk. This one is the disk 1. Disk 2. This is disk 1. This is disk 2. Disk 3. Disk 4. Disk 5. Disk 6. Disk 7. And this is the disk 8, right? So suppose some information, suppose you have the 1 byte, right? 1 byte of information. So suppose 101110. For the sake of simplicity, I only takes the 10, right? So 10 and the 1. So how to in this is the 1 byte of information. So first bit we kept in the disk 1, right? So here we can keep, and the second information also similar for the second disk also. In this way we can uh, this information we kept in here, right? I hope it is clear to everyone. So we means only one bit is kept on the disk, one disk, right? So is it clear to everyone, so that how's the bit level stripe is there, right? Hello. Yeah. And the same in the byte levels, we suppose there is a file. Suppose let's take one, my file .doc is there. So in the byte level, what will do, we divides the byte in we divides this in this file into the byte. byte, and the each byte we stored in the a disk. Suppose there is a 4 disk. Disk 1 and disk. Suppose this is disk 1, this is disk 2, this is disk 3, and this is disk 4, right? And this information we divided into, let's take the 4 byte. So this is the byte 1 and byte 2, byte 3, and so byte 4. So each byte is kept in the one disk, right? And the block level, similar things. We divided the each block of that file is kept in one disk, right? Hello, am I audible, right?
Yes, sir.
Yeah, thank you. So you know about the parity bit. So in the parity bits means, suppose there is, so suppose you have the array of bit 1 0 1 1, suppose, and suppose this one is a parity bit, and this bit is a use for the this bit is a use for the error detection or the error correction, right? So this particular bit, suppose this all are the data bits, and this is the parity bit. So we in this course we use for the XOR operation, XOR, right? So suppose this is the can anyone tell what is the XOR operation of between the 0? So first tell me the table. uh, what is the value of, suppose one absorption, that is 0 0. What is the value of that? 0 0 0 1 1 0 and the 1 1.
False.
This is the 0 0 means 0, right? False means 0, right?
Yes, sir.
And 1 0 0 1
True. 1.
1, yeah. And 1 0, similar things, 1,
Again 1.
and this is 0. So
0.
tell me what is the value of that. First, you can do in the any orders. You can go from left to right, and the right to left answer will be the same. So this is the zeros, 1 0, that is 1, right? 1 1 0, right? And this one value is 1 0 1, so, and this is 0. Then this is your, if this is given, suppose this is given, parity bits, this is given, and so you find uh, do the that XOR operation and you get 0. That means what? There is an error in this particular bit. So in this way we can find the error, right? Hello, is it clear to everyone, right? So what is the original parity? So suppose if this is the 1, then we get the this, then our data bit is correct, right? Hello, it is understand it is clear to everyone, right? What is, so it is clear to everyone, right? Yes or no? So after that, we will see this what are the standard grade levels are. There is the most common are the RAID 0 and the RAID 1, and it's have several variants of that, means combination of the nested 0 1 1 0 and the RAID 5. We check one by one, right? So so this is the RAID 0 is the we do strafing. So what is the strafing we see? So suppose there is the data file or data file that consists of right. So first check ends the RAID level 0 only use the data struct. No redundant information is here. If one disk is fail, then all the information in the disk array is lost, right? And here independent of the numbers of the disk and the effective space utilization hence the RAID level 0 system is always 100%, and RAID level 0 has the best write performance in all the RAID level because the absence of the redundant information and implies that no redundant information need to be updated. So can anyone tell what does this point means? How it is used the 100% storage efficiency is 100%.
There is no repetition. Complete
Y-
space is utilized.
yeah. That is here you can see there is no repetition. Uh, Means we divided the data into blocks. Suppose assume that this is a block and this is a block. Suppose. So these are the data files we divided or stripped in that eight block. Suppose this is eight, A2, A3, A4, A5, A6, and A7, A8. So first we give this first block give in the first disk and this information in the second disk, and similar things we repeat here. So what is the formula for the storage efficiency? Tell me what is the storage efficiency? So that is the number or you can say the size of non-redundant storage divided by total size of storage. So suppose this is the 5 GB storage, this disk, and this is also 5 GB, right? And it completely full, right? So what is the storage efficiency for that? How we calculate? So there is no redundant information, you can see. No redundant information. So size of non-redundant storage is that is the 5 GB plus 5 GB, right? And the total storage is that is 10 GB. And that is 100%, right? So I hope this point is clear to everyone. And the second point, you can see the RAID level 0 has the best write performance of all the RAID levels because the absence of the redundant information. So anyone can tell what is this point means?
No repeated writes.
No repeated writes. suppose you see in the mirroring that if you want to write here, so suppose here you have to write A9. So in the mirroring, you also have to write since the disk too, right? But here not the same case is here, right? So you have to write on some only one disk at a time. So that's why the write performance in the RAID level 0 is good. And reliability is very poor. So why the reliability is very poor in this? So here you can see only one copy of data is stored in the disk. So here on the disk 0 and 1, right? So if this block got corrupted or it lost, so you cannot recover it. So all the data information get means you lose all the information, right? So if one block got corrupted, so all other information is the meaningless to you. It is just a array of bits, right? So that's why the reliability is very poor in some RAID level 0. I hope it is clear to everyone. So what is every point in the RAID 0? So we come to the next, that is the RAID 1. And so here we use the mirroring concept. So as the mirroring concept means so suppose there is a one disk, right? So we make the similar copy of that disk. If we store the A1 block here, so we similar thing we stored in the disk 1, right? Here, similar. So just we copy the data value. So in this way, one point is there. Here, the reliability is very poor in the RAID levels, but with respect to the RAID level 0, here the reliability is pretty good, means good. So if one information in one block, we lose one, this block got corrupted. So we can retrieve the same information from the disk 1, right? But here read write performance is for the write, it is costly. So suppose if you want to write here, so you have to write also here. And for the read purpose, you can read from either disk, either from the disk 0 or from the disk 1, right? So let's go through the point one by. Hence the RAID 1 employs the mirroring, maintains the two identical copies of the data on the two different disks. It is the most expensive solution. Hence the expensive in term of the storage. We store the same information on some multiple disks. Here we store in the one disk, maybe you store this another disk also the same information, that is also possible. And the third point is the excellent fault tolerance. So this point is clear to what is the fault tolerance means. Yeah, fault tolerance means that things if you lose one block, then you can also get from the another block, right? So every write of a disk block involves the write on the both disk. Here we discuss about, and with the two copies of the each block exist on the different disk, we can distribute the read between the two block and allow parallel read, right? That is also possible. And the RAID level 1 do not strive the data over the different disk. Thus, the transfer rate of the single request is comparable to the transfer rate of single disk. So can anyone tells the last point? What is the storage efficiency? How we calculate the storage efficiency? So suppose this is the storage capacity of the first block is 10 GB, and this is also 10 GB. Hello.
10/20.
10/20. So first size of non-redundant, right? So size of non-redundant is 10 GB by total storage. So that is 10 GB plus 10 GB into 100. That is 10/20. That is we can say in the storage efficiency in the RAID 1 is 50%, right? And after that we see the parity bits. In the RAID level 2 we use the parity bits. So already we have discussed about the parity bit. What is the parity bit, right? So in the RAID 2 we use the parity bits, and here we use the Hamming code for the parity bits. So suppose there is here you can see these are the data bits. So assume these are the data bits, and if the 4-bit data bit is there, so how many uh, parity bits are required for that? So that is the 3-bit is required. So suppose these are the data bits, right? And this is the parity bit. So suppose here any error occurs, then I will everything is fine. If suppose this is for detect this one, I use for suppose for the here parity bit I gives just assume that's the parity bits I gives 1, and for 0 I gives 0, right? So for that, if error is there, then I say this is no error for the there is no error is there. And so let's take error. So suppose parity 1 is any error is there, then we put 1 and the 0, and for the 0 1 and so if no error, then we can see then we can say 0 0 0 0 right. 0 0 is already there. So how many bits are required for the 2 bits long information? Can you for the general just so there you can see there is a three parity bits. So 2 parity bits, but the number is required, right? For the are you able to follow me, right? Hello. Hello. Yeah, you are getting my point, right?
Yes, sir.
Okay. So suppose there is the so here you can see Suppose this is the redundant or the check bit, right? C is the numbers of check bit, right? Redundant. So these are the redundant bits, right? Or check means you can say the check bits or the parity bits. Let's the parity bits. And this is the data bits, right? And that is the D. So for you can say that is here for the we simplify that one. So you can say the 2 to the 4, that is the C check bits is greater than equal to D plus C plus 1, right? So you can check here. There is a 2 data bits, right? 2. And yeah, okay. So here check bits is not 2, that here is a 1, right? So we take this example, right? So that is the 2 to the 4, 3 greater than 4 plus 3 plus 1, right? That is the 8 is greater equal to 8. Hello? I hope you gets the bit idea about how this. So you can go through the slide and the lecture video, you gets the idea about that. So in the RAID level 3, we use the byte striping and also use the parity bits. So in each here in each disk we kept the byte 1 byte at a time, and for each bytes for the corruption for error detection we use the parity bits for that, right? So this disk is only used for the parity means the parity bits. So can anyone tell what is the storage efficiency for this one RAID level 3? Anyone? What is the total size of the redundant?
75%.
Yeah. So please tell me what is suppose this each one of is the 5 GB. So what is the non-redundant information? Which block are stored the non-redundant information?
0, 1, and 2.
0, 1, and 2, and that is the 5 GB. Right. And the total storage is 4 into 5 GB. So in the RAID level 3, there is the storage efficiency is a 75%, right? So here you can see one thing, for the every write operation. So suppose if you want to write this, update this this byte, right? So for that you have to also update this parity bit also, right? So this is this is one overhead here for the this disk also, and one problem is there. Suppose if you this disk got corrupted, right? So you cannot recover your if any data got corrupted in between this disk, so you cannot recover, right? Here, hello, this this disk is store the parity bit, right? So if this disk got corrupted, so then all the information got get loose, right? So this is one overhead for that. So that every time you write any in this disk, then you have to also update this. So every time, so it is always in use, right? So for that one drawback, that we can distribute this parity bits over the every disk, right? So in this way we can solve this problem. So in this way we cannot lose the parity bits or the check, that single check disk information. So for that, okay, this RAID level 3 and the RAID level 4 are the pretty similar. Here we divide stripe striping in on based on the byte, and here striping based on the block, right? And so we solve that problem, so that drawback ends the RAID level 5, right? So in the RAID level 5, what are here whatever's we stored in that check disk, so we distributed over the each disk, right? So here you can see, so the check bits here the check bits we stored in this particular, and this one is the this. So in this way we distribute over all over the disk. So here you can say the what is the storage efficiency, right? That is also the 75%, right? Hello. So these are the redundant information, right? Hello. Uh, you check. You can check the storage information of this and try to find out, and we discuss on the next session, right? So it's the RAID level 6. We use the dual parity. So you can see. This is the one parity bits, and this is the another parity bits. In the dual parity bits, we can recover here in the single parity bits, we can recover only the one. If one bit got corrupted, then we can recover using the one that parity bits, right? But in the double parity bits, we can use the we can recover the 2 bit, right? So can anyone tell what is particular, what does this point means? The right performance of RAID 6 is the poorer than the RAID 5, and how it is?
Has to write one more parity, two parity for every update.
Yeah. So suppose if you want to write here, so you have to calculate the parity bits for this one, right? So you have to update the parity bit, right? So that is we did in the RAID 5, but similar things we have to do for the second one. So this is this in this way we uh, means degrade our performance also, right performance also, right? And for the RAID 6 we use the read Solomon codes to recover from the update to two simultaneous disk failure using this two parity bits, right? So after
What
we
is that rate Solomon code?
yeah, this is just you have to, so this is not in your syllabus, so you can just say that.
Okay.
Hence the hybrid RAID or the nested RAID labels we can nested we can in the hybrid RAIDs we use the two RAID labels, suppose the 0 1 and the 1 0, we can combine together for the better performance and all the advantage and the performance of the one. Suppose the RAID 1 advantages and the RAID 0 advantages we can get the uh, together, and this will means in this way we can get the better performance, right? So here you can see RAID 0 1 is the first we use the RAID level 0 and then we use the 1. Hence the tell me what is RAID level 0 will do. In the RAID level 0 what we have done, we
Split
strifing
Stripe.
right. So here you can see in the we striping that value, right? A1 keep in one disk and the A2 value in the another disk, and right. So that is the RAID level 0, and we in the RAID 1 we do the mirroring, right? So we make the same copy of the data here, and right. So similar 1 0 first we applies the RAID 1, that is the mirroring one, and after that we striping that data bits. So in this way we gets the better performance. So and these are the theory part you can check out, and if any problems there, so we can discuss on the next session, right? Any doubt? So you got an idea about that's the RAID part, what will RAID do and what are the RAID level are there, what are the advantages, right? And everyone know about the XOR operation, right? So for the check means we use the XOR operation. So okay.
Sir, in a practice assignment, there's a question for converting into ASCII code, right?
Question number, can you tell the question?
I don't have the question right now. Practice assignment, we are using the parity and converting it into ASCII code.
Parity bits, ASCII codes. So you know about the sky A. Can you tell what is the sky code for the A?
Don't remember exactly.
That is 65, right? So you can only you have to remember these things, and other thing you can add up. So suppose Z is 65 plus 25, right? I think so. That is 90. I think that is you can find out the 65 is A, and you can add up to that, right?
So with 7-bit parity, how can we convert this to A, or like, should we convert it into hexa, or
A 7-bit parity bits. So suppose this is the 1 bit, 1, 0. So 2, 3, 4, 5, 6, 7, right? So for the 65, you have to how to we finds the binary number. So 64 you can mm, or you can add up 64 2 to the 4, that is 30, that is 60. Yeah, you know about this, right?
yes?
Or yeah. So this is 2 to the 4, 6 is 64, right? 64, or 2 to the 4, 0 is 1. So that is 65. So this is the ASCII code or for the A or the binary code, right?
Yeah.
Yeah. So I think here only the 7-bit is the sufficient.
Okay.
So
Got it.
yeah, yeah. So I think now you can do that. Right. So I think in that question you have to do what you have to do. I'm just guessing. So suppose there is a given the 5 disk, right? Disk 1, disk 2, and the disk 5, right? And disk 5 is contains the parity bits, right? So one of the value got corrupted, right? And you have to given the 7-bit for this disk 1, and 7 disk for this one, and this one for the 7-bit, right? And the
Yes, sir.
parity bits also the 7 bits you have given. So you have to first you have to find the this 7 bit, what are the 7-bit here. So how you can do that? You can do the XOR operation.
Yes, sir.
So yeah, D1 XOR, D2, and the D3. D2 is not given, so D3, D4, and the D5, and you gets the bits of D2, right? And if you gets the D2 bits, 7 bits, so now you can find the what is the numbers, means a decimal to converts this decimal value to this binary value to decimal value, right?
Got it, sir.
Yeah, and then you find the corresponding word. So suppose that is the 62, 66, then this is the B, 65, A, and in this way you can find the 4 letter, right? Yeah. And everyone know about how to find the storage efficiency, and so this is one problem. In this way you can solve some problem, I think. So hello. Yes, Subin, carry on.
Hello, someone have doubt on MTF question. Hello. Hello, am I audible, right?
Yes, Subin, you are audible.
So someone have doubt on MTF, so let me share my screen. Okay, so this question, right? Hello.
I think he's not present here right now.
Okay, so let me solve the question. Okay, so you are the sorry, 1 minute. The question is, you are the quality engineers of a magnetic disc manufacturing firm. While testing a set of 30 discs for 24 hours, you observe that 15 discs fell after 18 hours, 8 other discs fell after 22 hours, and the remaining discs are never filled. Then what is the MTTF for 15 discs randomly selected from the sets? So let's solve the question. So MTTF for one disc of the set equal to total time for which the discs work by number of discs filled. Okay, so MTTF for one disc of the set will be So see, 15 disks fell after 18 hours. So 15 disks work only for 18 hours. So 15 disks into 18. Then 8 other disks fell after 22 hours. So 8 disks fell after 22 hours. Then total work will be 22 hours. Sorry. Okay. Then remaining other disks will work for 24 hours. So 15 disks plus 8. 15 plus 8. So 15 plus 8 will be 23. And 30 minus 23 will be 7. So 7 disks work for 24 hours. So everyone got it, right? Hello, am I audible? Hello.
Yes, sir. This part is clear.
Okay. And the total number of disks is number of disks fell. So number of disks fell in 15 disks fell, and the 8 disks fell. So 15 plus 8. Anyone? 15 plus 8 is 15 plus 8. So if anyone want to, so what will be the 15 into 18? Okay, so let's calculate. So it will be 810 plus 8 into 22 will be 176 plus.
It will be 270, right? Not 810.
Okay, sorry. 10 into 18. Oh yeah, sorry. So what will be the 15 into 18? 270, right? Hello?
Right.
Okay. So what will be the 8 into 22?
176.
Yeah. And what will be the 7 into 24? Anyone?
168.
Okay. 168. And 15 plus 8 is 23. So what will be the 270 plus 176 plus 168?
614.
Okay. And 4?
614.
Oh, sorry, 614. Okay. So 614 divided by 23.
26.9. 26.7. 26.7.
Okay, 26.69, right?
Right.
Okay. So amplitude TF for one disk of the set is 26.69 hour. It is hour. So now they have to find amplitude TF for the 15 disks. So randomly selected. So amplitude TF for a set of 15 disks will be 26.69 divided by 15. So anyone, what will be the result?
$1.78.
Yeah, 1.78 hour. So anyone have the doubt in this question, you can ask.
Sir, I didn't understand why are we dividing by 15 discs?
So see, 15 disks is randomly selected.
Right.
So
Like in the first case, we calculate 26.69 hours. That means one
For
disk
one-
will fail on an average for every 15 hours, correct?
For no. For MTTF one disk is every disk will fail every 26.69 hours.
Sorry, 26.69 hours. So one
Uh,
disk will fail every 26.69 hours.
yeah. So if we
So
kept 15
yes,
disks,
yeah.
if we kept 15 disks, then it will divide 26.69.
But for one disk it is 26, right? So for
Yeah.
15, shouldn't I multiply? Why are we
No,
dividing?
no, it is for no. So for one disk, it may fail 26.69 hours. So if we randomly selected 15 disks,
Huh?
so
That means every disk in that 15 disk on an average could fail for 26 hours, right?
and
So I have to do 26 into 15.
no. Actually, see, um, okay, how it means. Mm, uh,
Like in the I'll just take the lecture example itself. So in the lecture it is mentioned that there is a set of 1,000 disks,
yeah.
and if one disk fails every 1,200 hours, 1,000 disks mean time to failure is 1,200,000 hours.
See, it means see, it will. You have chosen 15 disks randomly, so
So that the like concept is still not clear. Like even if we've chosen randomly, like we are calculating average, right? So we don't know how many disks will fail.
uh, mm,
Hello. Hello. Hello.
yes, Pradeep.
Am I audible? Someone is asking, I think.
Yes, sir. Yeah, hi, you're audible.
Yeah. So what you have just said, that is correct. What you have said, that's if a system consists of the 1,000 disk and the system MTTF, that is the system MTTF is given to you, that is the 1,200, I think 1,200 hour.
Okay.
Okay, that is the system MTTF.
Okay.
And if you want to find the MTTF of the one disk, that is, you have to multiply it, right? And you can understand also in the reverse way. That's the one disk. Suppose one disk is am I audible, right?
Yes, sir. Yeah.
Yeah. So is my screen is
Yes, sir. It's visible.
so suppose MTTF of what you have said, that is the MTTF of one system is 1,200 hour, right? And the
No,
system consists,
no,
yeah,
it's given as MTTF for one system is 1,200,000 hours.
yeah, 1,200. No, that is, so let me explain in this way. So suppose a system consists of 1,000 disk, right? So this is the consist of 1,000 disk, is there is a 1,000 disk, right?
Yeah.
And the one disk is, that is what you said.
Yeah.
What is the total, is that 12 something is there, the number
Yeah, so it is given as one disk fails every 1,200 hours. That means the
No, no,
MTTF,
no, no. Tell
yeah,
me the total.
a total, like the overall, this thing is 1200,000.
1200. That is the
Yeah.
yeah.
It's given as one disk fails every 1200 hours in the slide.
So in the previous slide, just there I explained the previous. Hello. Is it visible, right?
Yes, sir.
Yeah. So I just explain here. Right. This is MTTF.
Yeah.
Yeah. So here you can see the MTT of the 100 disk is 100 disk is
100,000.
no.
Okay.
One system consists of 100 disk, right? And the one disk MTTF is the 1 lakhs, right?
Okay.
So what is the system MTTF average? That is, you should divide it into that 100, right? So then you get the system MTTF.
Okay.
So what you have said, that is, you said these things in the reverse way. You said that the system MTTF is this, and you have 100 disk, and you have to find the one MTTF of that. So
Okay.
in that time, you have to
I
multiply.
got it.
Yeah.
I understood. Okay, I think that's clear now. But in that question, I still have a doubt. Like the 26 that we've got, right? Is that still for one disk, or is it for a set of 15 disks then?
Uh,
Okay, I think I understood. So we're saying that if one disk fails every 26 hours, that means no, I'm still confused. In that question, I'm still confused. This part I understood.
yeah. So at the end of that, the 15 disk is given. So you assume that's the, just for assumption, you assume that's the, now the disk, once you have finds the total, means total MTT of one disk.
Yeah.
Yeah. So after that, you assume the 15 disks consist of the one system. One system consists of the
Okay.
15 disks.
Okay.
Now you can.
Yeah, that's an assumption, right? Okay.
Yeah.
Okay. Thank you.
Thank you. Yes.
So am I audible? Hello. Hello, Soumya, am I audible?
Yeah, Svendu, you told.
Okay. So in the quick 12, so mainly, so basic three types of joints: nested loop joint, and the second is block nested loop joint, and the third is indexed nested loop joint. So today we will cover nested loop joint. Then we will solve some numerical using nested loop joint. Okay. So we will see how many block transfers required and when and the numbers of 6 required in nested loop joint. So what is the nested loop joint algorithm? So suppose, okay, so so let me so try to, okay. Okay, so suppose this is the secondary memory. So, and this is the table 1 outer relation, and this is the table 2 inner relation, and the table 1 consists of, suppose, one block, two block, and the three block, and each block consists of 3 record or 2 record: record 1, record 2. So in this example, we'll show index nested loop joint. Suppose record 3, record 4. Record 5, record 6. And the table 2, each block consists of, suppose, 3 records. Suppose record A, record B, and record C. And it consists of blocks. Record D, record E, record F. And suppose, sorry, suppose this is the main memory. Okay, so what happened in nested loop joint? So each block of table 1, suppose this is table 1, and each block of means it's come one by one. Suppose it's table 2, So suppose this is a record 1 and record 2. Suppose this is a record A, record B, record C. So what happened in nested loop join? First record 1, it's compared with record 2. So if it matches, so then in the outer means it's matches, then it's that means suppose there are students and the text. Suppose there are two tables. So suppose roll number and the suppose name and the course ID. Suppose this and the name is this is the suppose 1, 2, 3 and ABC and the text. So suppose roll numbers and the course ID. So roll number 1 and the course ID suppose 1. Suppose roll number 1 and the course ID 2. In this suppose roll number 2. So suppose record 1 it's matched with A. If it's matches, suppose suppose 1 it's matches with A, means if matches, then join only writes. So student and student table and text table it's join and it's writes the records. And the next time record once it matches with record once, then matches with record C. Then after the record once completed, then suppose this is a block 1, this is the block 2. Then block 2 moves in the main memory. Then what happened? It's in block 2. Suppose record D, record E, record F. Then record 1 matches the record D, record matches the record E. Then record 1 matches the record F. After that, record 1 is completed. After that, what happened? This is the suppose in the table 1 relation is a block 1, is a block 2, and the is a block 3. So after the completed record 1, then what happened? Record 2, block 1 will be moved. A, record B, and record C. So record 2 matches the A, and the record 2 matches the B, the record 2 matches the C. After that, block 1 completed, record 2 will be moved in the main memory. Suppose record block 2 is moved. So record D, record E, record F. So it is message with the record 2 means D, then message with the E, then F. After the record 2 completed, what happened? This block 2 moved in the main memory. So everyone got it how nested loop join works? Then same things will happen like the block 1. Everyone got it? Hello? Am I audible, right? Hello?
Yes, sir. You are audible.
Yeah, you got it.
Yes.
Okay, so then the question is, okay, so suppose hmm, um, suppose suppose the number of record is NRs in table 1. So table 1 number of records is NR, and the numbers of block equal to NS. Sorry, yeah, NS. Sorry, no, sorry. Suppose numbers of block is BR, and the table 2 numbers of record is NS, and the numbers of blocks is BS. So total numbers of block transfer anyone in nested loop join? This is the table 1 is the outer relation and table 2 is the inner relation. Anyone?
What is that, sir? Total number of block?
The transfer required. For nested loop join.
I think it will be NR into BR.
NR into BR.
We, sir, NR into NS.
So see, again I'm explaining what is nested loop join. So then it will be clear. Okay. This is the secondary memory, right? It consists of table 1 and table 2, and this is the outer relation and this is the inner relation, and this is the main memory, suppose. So what happens in nested loop join? First, block 1, table 1 of block 1, it's moved to the main memory. Record 1 like 2, and table 2 of block 1, it also moved to the main memory. Record A and B and C. So in this case, what is the block transfer? In this case, 1 block transfer and the 2 block transfers into the main memory. You got it?
Yeah.
So then, okay. So what will happen? First, record 1. So record 1's, it's compare with record A, record B, and the record C. Then again, after the completion of block 1, again what will happen? Block 2 moves, and it's compare with record D, record 1 compare with record E, record 1 compared with record F. After that, what will happen after record 1 completed? After that, what happened? Again, block 1 move to the main memory. Then again compare with record 2. Suppose record 2 compare with A, record 2 compare with B, record 2 compare with record C. Then again after that, block 2 move to the main memory, just like this. So what will be the block transfers in the nested vision?
So, sir, for each block in the outer table,
Yeah.
all the blocks in the inner table are compared.
Yeah, on the, yeah. So and the one block transfer is, suppose this move to the main memory, then the one block transfer. This block to the main memory, then one block transfer.
Yes, sir.
So total numbers of block transfer will be
3 into 2. So I will have NR into BR into NS into BS.
Plus
No.
BR. Plus BR.
NR into BS plus BR. Everyone got it? This formula. You have to don't remember if you understand this.
No, sir. No, sir.
Sir, NR into BR into BS, right?
No.
For each record, you are
So
moving.
let me explain 1 second. So you will get it. Okay. Okay. Suppose in table 1's total numbers of record is NR.
Sir,
Yeah.
it would be better if we quantify them, like put a number in this, and then
Okay. Yeah. Okay.
just instead of NR, like write 6 or 5, something like that. That would be.
Yeah. Suppose this is the this is the secondary memory. And it's consist of, suppose 3 block in table 1. One block, 2 block, and table 2 consists of, suppose 2 blocks, 1 blocks and the 2 blocks. And records are like records 1, records 2. Okay, and the records, each block consists of 2 records. So for example, record 3, record 4, record 5, and the record 6. And the table 2, like each block consists of 3 records: A, B, C, and consists of, suppose, D, E, M. And the table 1, for table 1, this is table 1, and this is the outer relation, and this is the table 2, this is the inner relation. So for table 1, total number of record is, anyone? Total number of record is 6, right?
Yes, sir.
Okay. Total number of 6, and the total numbers of block. Block is 3. Okay, so for identify, let's, it consists of 2 records per block. For table 2, total numbers of record And total numbers of block?
2.
Okay. So what happened in nested loop joins? It's moved first block. First block of table 1. It's moved to main memory, and first blocks of table 2, it also moves into the main memory. So total numbers of block transfer is 2, right? Now until now.
Yes, sir.
Okay, suppose in the records 1 and the record 2 and the record A and the record B. What happened in the again I'm explaining what happened in the nested loop join. First record 1 compared to the A, it's if it matches, then it return to the join. Then record 1 compared with the record B. After completion of block 1, what happens? Block 2 move into the main memory. So what happened if into the main memory? So record D and a record E. So then it matches with the 1 with D and the so record 1 it matches with the record E. So everyone got it. So total number of until now block transfer is
3, sir.
3. Then after completion of record 1, what happened?
Record
Again block 1 move to the main memory. Main memory, and it's compared with, suppose if we block 1 suppose it's block 1 move to the main memory, then A, then B, and the record 2 compare with A and record 2 compare with B. So total numbers of block transfer until now is,
I mean, if
Four.
all the blocks are transferred, then 5.
No, suppose record 2 until block 1, then 4.
Okay, then 4, yes, sir.
Okay, 4. Then after the block 2,
Then it's 5.
then it's 5. You got it?
Yes, sir. Now, yes, sir. Till this one, till this much I got it.
Okay. Then what happened? This block 2 is moved.
Yes, sir.
So this block 2, then total numbers of block transfer is 6, right? You got it? Then block 1 is against transfers. You got it?
Yes, sir.
So if you in this way, if you go it, then total numbers of block transfer will be total means whole. I am explaining in the whole. So suppose the total numbers of record 6, then total numbers of block in table 2 6 plus 2 plus total numbers of block in the table 1 plus 3. So for every record you will move one record, right? For 1 it's moved to the block 1, then for 1 it's also moved to the block 2 records. So for every records it will move, so to 6 into 2, and the each block will be moved into the main memory. So 6 into 2 plus 3. Abhishek, you got it? Or
Yes, sir. Yes, sir. I mean, 6 here. 6 is the number of records in row table 1, right?
6? No, I'm explaining total numbers of block transfer.
No. The formula you wrote here. I mean, in the
Yes,
right.
yes. 6 is the number of records in table 1.
So 6 into 2. 2 is my block. Okay. So for every record, I am comparing 2 blocks, and and I am taking all the 3 blocks. Yes, sir. Now it's clear. Now the
Okay.
formula.
So now I'm explaining the types of formula. Suppose okay, so suppose total numbers of records in inner relation is NR, and our total numbers of block in inner relation is suppose BR, and the total numbers of records in outer relation is NS, total numbers of block in outer relation is BS, then total numbers of block transfer will be anyone? Hey, anyone?
NR
Sir, ER into PS plus
plus
BR.
BR.
Okay, NR into BS plus BR. Everyone got it? You have to remember this formula. If you got the concept how nested loop this work. Okay, so based on the this we'll solve some numerical.
Sir,
Okay, yeah.
sir, is this I mean, which kind of join this is talking about? Natural join?
Yeah, this is nested loop join.
No, I am nested loop. I understand, but which join is happening here? Any kind of join can happen.
Yeah, it means
I mean, we saw many types of join, right? Like natural join, then
uh, uh, mainly work on equation. Equation. Hello.
yes, sir. Yes, sir.
Equation.
Oh, okay.
So I've also equation, mainly equation. So okay, so based on this we'll solve some numerical. So let me suppose one is so sorry, numbers of records of a student. This is the student. This is means this is the table name student. So an student is suppose this is 5,000, and the numbers of the record of text and text will be, suppose this is the 10,000, and the numbers of blocks of a student B students equal to 100, and the numbers of blocks tax is B tax is 400. In the first case, student as a outer relation. The number of block transfer is anyone? I'll wait 1-2 minutes. Please solve. Then I will solve. Everyone got the what is the question? Hello, Abhishek.
Yes, sir. Yes, sir.
Okay,
Sir,
I will wait 1 minute so that everyone can solve. Then I
okay.
will. Yeah. So anyone? What will be the numbers of block transfers? Neeraj, would you want to volunteer?
Yeah, sir. It will
Yeah.
be around 2,100,000 transfers.
Okay, so can you write step by step? So that will be better.
Okay. So first we have to take the number of records in the outer table.
Yeah. So that is
which is
5,000, right?
5,000.
Yeah. So
Yeah.
yeah,
And
5,000.
and then number of blocks in inner table.
Yeah.
Which is 400.
Yeah. It is 400.
Plus number of blocks of outer table, which is 100.
Yeah. It is 100. Okay. So it will around 200.
0
1
100
block transfers. So everyone got it? How this result come? Okay. So next question is a text table text outer relation means this table text table. So then what will be the numbers of block transfers? So I will wait 1 minute. We can solve. So anyone want to volunteer? Mm. Manasita? Pras, would you want to volunteer? Hello, am I audible, right?
Yes, sir, you are audible, sir.
Okay, so
Yes, sir.
numbers of block transfer will be
Number of block transfer will be number of records in text,
which is
10,000.
Yeah.
Into number of blocks in student,
Yeah,
which is
which is
100,
yeah.
and plus number of blocks in text,
Yeah, which is 400, right?
400.
Okay. So it will lay down 400. Okay. So everyone got it. So in the next live session, we'll discuss block nested loop gen and the index nested loop gens. So if you have doubt in this, means in the nested loop gen, you can ask. And any doubt in UPL other than this?
Sir, one thing, sir, for the exam, I cannot prepare for week 11 that much. So I watched the session, but I did not watch any previous session. I did not attend any previous session. So will there be any other session after this week 12 so that we can clear our doubts there if we have some doubts?
Piyush sir?
Hello. Yes, yes. So after week till we can plan one session where you can ask any doubt from week 1 to 12.
Yes, sir. That would be really helpful, sir. Thank you.
Okay. Yeah. Okay. Any other question? Okay. If no further question, then we can close this session. Yeah.
Thank you, everyone.
Thank you, everyone.
Thank you, sir.
Thank you. Thank you, everyone.